what safety stock is. It is the backup, right? In case some uncertainty happens, in case lead time, there is a change in lead time. So uncertainty can happen both in terms of lead time, both in terms of demand also, right? So if there is a decrease or increase in demand, most probably we are looking for an increase in demand, right? Or there is a, let's say your supplier from where you are taking material supposed to deliver within 5 days. Rather than 5 days, sometime it takes 7 or 8 days. So you have to be also kind of ready for that kind of challenge. So whenever uncertainty happens, safety stock requirement happens for two reasons: uncertainty on lead time, uncertainty on demand, right? So sometimes it might happen that we have excess safety stock, excessive safety stock ESS situation might arise. We have, let's say, 100 or 50 quantity of safety stock, but maximum for the last 1 year or 3 years, what I have seen or what we have seen, maximum consumption has happened 30 units. In that case, what happens? You have always 20 units. So I guess we have discussed the economic order quantity. It is not only about the money which is tied in your inventory, right? Because when you say that, okay, this much inventory you are keeping it as a safety stock, you are paying to that retailer or supplier for that much inventory. So that cash anyhow is kind of tied up. That cash is anyhow like with the supplier or with the vendor. Second part, obviously the problem is with the carrying cost, right? The holding cost, the amount of money it requires, let's say for certain kind of product, milk products, soft drinks, you need to have a cooler or you need to spend certain electricities apart from space. Certain kind of heavy items, certain kind of let's say production level items, you need special machines, special equipment, transporters to transport those material, right? So all this will be adding to your inventory cost, carrying cost or holding cost, right? So it is not only about the money tied up in the inventory, it is also about keeping that material, keeping that product in your warehouse or in your store safely, securely, so that that can be sold to the customers, right? So these are the four terms which will be important for us. Why we are telling this, we are going to use once this class over, next class we'll do something on the network optimization, right? So in that software we'll change certain inventory control, right? We'll change certain lead time, we'll make sure that if we change those inventory control policy, how you manage inventory across your warehouses, across your plants or manufacturing plants and your warehouses, right? What is the changes in optimization? What is the changes in simulation, right? So T is the replacement interval, that is the lead time, right? So that is the time the supplier or the vendor will take to send the material, send the product to you. Q is the order quantity, small q. S is the reorder point. Again, reorder point, remember it is not time frame, it is the quantity. The amount of inventory left with you when you are placing an order. So that by the time order reaches you, you would have consumed, you would have sold all the inventory, right? So again, reorder point is not a time, reorder point is the quantity. Then S is the target inventory level, right? Sometimes S will be included, like in this particular case, my target level can be along with the safety stock, or it can be without safety stock also, right? So keeping these four parameters in mind, P, Q, S is reorder point, S is the target inventory level, how much we want to keep, what is the maximum stock we want to keep in our store, right? So with a simple example, we'll take four situation, different type of inventory control policy. Again, the same example for a small grocery shop, because if you can understand in that small example, you can think of for a bigger organization. Obviously, challenges will be a little bit more complex. Small grocery shop, regularly he is ordering some items from the supplier or the wholesaler, right? Big wholesaler, he is ordering certain, maybe the regular consumables, right? Milk or atta, chawal, whatever it is there, right? Fixed time between two orders, fixed order quantity. So what it means? Lead time is fixed, your demand is also fixed, which is the very normal situation, right? And most of the small stores follow that, right? So thus it is recommended to implement this policy under constant demand. When you know that, okay, if I am supplying, like in the apartment where I stay, there is a small grocery shop. It is kind of handling those because it is inside the apartment building. It only caters to those 400 or 600 apartment which are there in that complex. So what it happens, because that shop has been for last 5 years or 6 years, Right now, at this point of time, they know for each of the product in their store what will be the weekly demand, right? Almost like kind of confirmed or a fixed unit of demand. So what happens per week? He will be ordering certain fixed order quantity and the delivery time, fixed time between two orders, right? If I put this order, let's say tomorrow or today evening, Thursday, and the order will be reaching to me by Saturday or Sunday. Next Thursday evening, again I'll be putting that order. So that is the fixed time between two orders, then fixed order quantity, right? So this is where automatic control can be done, because if some material is there, automatic, like think about a big company like Maruti or Hyundai or Honda or like FMCG companies, right? If there are certain products, certain material or the modern retail, right? If they know that regularly from their shop, from the big bazaar or Reliance Mart, every week there is this much consumption of your wheat or rice or milk, so that they need not have to do much complex calculation. Every week, fixed amount of 500 packets or 500 kgs or 1000 kgs of order would be placed, right? Which improves quality, saves resources, because no need to like check, because for the last 3 years or 4 years you have been seeing that trend and you believe that that trend will continue, right? But again, like I said, it will be only used in the small cases, right? Very rarely it will happen that you will have a fixed demand, right? Unless you are catering to few group of people. Like think about, like in case you have been in our campus, our canteen, uh, on a day, particular day, how many like lunch plates or the dinner plates, they will have that idea, right? In these cases, it will work, but not for a like let's say big hotels or like kind of a big establishment, because it keeps changing day by day, week by week. The order will be fluctuating, right? Time also will be fluctuating, right? So this is where we recommended to implement this policy under constant demand, where you are aware that okay, demand will be constant from customers. Also, you have the control over how much time it takes for order to arrive to your location, right? From the supplier to your location, right? In that case, you can go by the TQ policy, right? T is the time it takes between two orders, and fixed order quantity, that is the Q, right? Then another policy is T and capital S. Capital S, remember the maximum inventory I want to keep in my store. That is the maximum limit what I can keep in my store. So what it happens, fixed time between two orders and variable order quantity to stock up to target level of S. So that is what I want to maintain. Think about the same shop, same grocery shop. He has a limit that he has told that okay, in my store, I'll keep at any point of time 100 kgs of rice, right? So 100 kgs of rice need to be the maximum stock level, right? So in what happens? Let's say this week starting from there, say next Monday or Sunday, right? So next week when this consumption happens, or this week which is ongoing, right? So by today, Thursday evening, he has already sold 50 kg rice, and every Thursday evening he puts an order, right? And it takes another 3 days to deliver. So what will happen? On this Thursday, today evening, when he checks that okay, 50 kg rice has been consumed or has been sold, he'll put the difference, because he wants to keep 100 kgs of rice, 100 kg minus 50 kg. So he will order 50 kg. Let's say next week when he is selling, by next Thursday, only 20 kg rice has been sold, right? Then what you will told, he will only put another 80 kg rice is left. Then only he will put order for 20 kgs. Whatever amount he is selling in that week, that amount only he is going to order from the supplier, right? But in the previous case, what happened? Irrespective of what is being sold or what is, because it is automatic control. In some day, let's say, unfortunately, you that the grocery shop owner fell ill and he closed his shop. He did not open his shop that day, right? Even then, also every week, because it is automated, order will go and fixed quantity of whatever rice or whatever items he is going to buy, that will be order would have gone, right? But in this particular case, you are doing a check. You are saying that okay, I have to maintain 100 kgs of rice or 50 bottles of, let's say, soft drinks, or 30 bottles of soft drinks. In this, by Thursday I have sold 20 bottles, so I'll order another 20, so that I'll still maintain the S, right? S is the maximum stock or maximum inventory you want to keep. Subject to lead time, order quantity is calculated as the target level is stock on hand. That is what you want to keep. Obviously, it avoids excess inventory. So you always try to maintain that inventory. The model is easy to use for control of orders. However, the physical control of inventory could be so expensive that exact count is only performed once a month, for example, right? Because you have to have a track record, right? Obviously, right now a lot of automation has happened. It is not that manually you have to go and check that how many units I have sold, right? If it is, let's say, modern retail, Reliance Retail or Big Bazaar, from the point of sale system, they have the information that okay, for a particular SKU, how much quantity they should keep, how much quantity has been sold, then how much quantity they have to order. But for a small grocery shop, if he doesn't have automated this point of sale system, he will not have an idea that how much units he has sold, right? He has to manually check. Okay, he'll go and for each item he'll check that okay, I have to keep 100 kg. I have already sold 80 kgs. Then I have to order another 80 kgs, right? Average inventory is high because you are always trying to maintain that high inventory, whether there is a demand or not. Even when per week, let's say there was only 20 kg rice was sold, then still you are ordering 20 kgs. Still you have 80 kgs left, but still you are ordering 20 kgs so that to maintain that level, right? So these high ordering cost because we might not place a large order. So this because your variation in quantity also happens, right? Some week to maintain that 100 kgs rice, you are ordering 20 kg. Some week you are ordering 80 kgs, right? So every week there will be variation in your order quantity, right? Which your supplier might not like. He might like in some cases if you are ordering a 10 kg or 20 kg rice, he might charge you additional transportation cost. He'll say no, no, I'll not take this much small order. I have to travel a lot of distance. I have to send my vehicle so that far. So you have to pay me additional 200 or 300 rupees, right? So that's where like because my order is varying, right? In the other case, what happens? I have a fixed agreement with the when the fixed time and fixed quantity. I have a fixed understanding with the supplier. Every week on Thursday, quantity of 50 kg rice will be ordered, right? Whether I'm selling it or not, that quantity has been ordered, right? But in this particular case, I have to do the manual check. Whatever I have sold in that week, that quantity I'll order. Recommended for use in conjunction with cycled replacement. For regular item usage, right, where you have this kind of manual check will happen, right? Every cycle there will be certain replacement. It will come, you will consume, or you will sell to your kind of consumers. Most of the modern retail outlets, if you see, they will follow three like that I was discussing, right? Obviously, it is most of the parties automated. Some parties manually check when the items come. They manually check. If some afternoon or noon time you go to any this kind of stores, you'll find most of them will be manually checking how much stock is left, how much stock they have to order, and accordingly order will be placed. Right. So that is where you want to maintain a constant level of inventory. Right. Capital is S is the maximum level of inventory you want to keep. Then small s variable time between orders or fixed order quantity, right? So your quantity is like kind of 30 kg rice or 30 units of certain product, right? But there is a difference in like depending upon how much order or how much items you are selling in that particular week, your time will vary. Sometime because let's say holidays are happening, Holi is coming, and lot of like sales has happened for a particular product, then that day within 3 days interval or within 2 days interval you'll start ordering, right? But normal week every week, so there will be a gap of 7 days or 10 days, right? The model operates when order quantity q is fixed and the interval t between orders can vary. In this order the order point is, so that is your reorder point, right? So that is again the quantity is defined as reorder point. Every order arrives to replenish inventory after a lead time. The lead time is assumed to be known and constant. The only uncertainty is associated with demand, right? One should most concerned with possibility of shortage during an order cycle. That is when the inventory level falls below zero. That is where you have to keep the safety stock. This is also called a stock out event. Every time we extract inventory, we compare that what is left with S, right? So anytime we are like kind of selling something, right? So that is the meaning of reorder point. If let's say I have 30 kgs left and I place an order, next day I sell 20 kgs, then I have to check that okay 10 kgs only is left, and which I have to like if lead time is 3 days or 4 days, I have only 10 kgs left. Sometimes it can be stock out also, right? If I do not have a safety stock. If the stock level is less than S, then we place an order at the rate of Q, similar to the TQ policy in the like your fixed order quantity policy. Q also refers to the optimal order quantity, the amount of Basically, this is the like kind of you will have a agreement with that supplier, right? Like I said, if there is a variation in Q, supplier will always agree for the additional quantity, right? Most of the times, unless there is a problem with the manufacturer, whoever that wholesaler or distributor who is supplying to you, if you add or if you like kind of order additional quantity, they will be always happy. But when there is a variation in the lower end, regularly you order 50 kgs and now you are ordering only 20 kgs, 10 kgs, they might ask you additional charges, transportation cost, saying that it is not the minimum order quantity what they want. So Q is the optimal order quantity which you are going to order. This is mostly used because depending upon like kind of because that fluctuation in time will happen when you are ordering. Quantity what you are ordering, right? You will keep it fixed so that you have a, because see like you have to also think about of the wholesaler distributor, right? They will not send you material unless there is a fixed order, right? There is a minimum order from your side, right? Or they might charge you extra, right? So in that case what you do, you have an agreement with the supplier. You will say that okay, uh, depending upon my requirement, I'll put orders, but I'll ensure you that, or I'll make sure that the quantity is, let's say, like half a truckload or a full truckload, so that when you are sending a vehicle, are not spending like basically your full utilization of the transportation vehicle is happening, right? But depending upon, let's say, I have a higher requirement, right? Think about whenever you go to a medicine store or whenever you go to like kind of your regular shop, right? For certain items which you buy, right? So you might have a kind of a agreement with him. If you buy like from the medicine stores, if you buy above 1,000 or 1,500, they'll provide you 10% discount, right? But my, and that is the agreement, and based on that discount, if I say that no, I'll buy only 500 rupees, they will not provide me that discount. So what happens? Depending upon the medicine consumption, depending upon what kind of medicine doctors is prescribing, that time when I'm going to buy that medicines might vary. But what might happen? I'll buy that minimum 1,500 or little bit extra, one strip or two strips, so that I get that discount. Same thing with your suppliers also, right? Whenever you are ordering, supplier, from suppliers point of view also, that is good, so that they also have a control over what kind of or how much quantity of demand is coming, right? So this is where your variable time between orders and fixed order quantity. Every time you are ordering from the supplier or wholesaler or distributor, you are ordering a fixed quantity, because based on that he will be providing you certain discount, certain like kind of relaxation on the transportation cost. Last one is where both are variable, right? You have a chance of like changing or difference in quantity required and difference in like kind of lead time, the amount of time it takes for suppliers to give you the material or send you the material, right? Order quantity and time interval between orders is variable, right? So the strategy is to define the drop of order quantity as after every inventory usage. Should this be the case, a manager should refill inventory to raise the inventory position level to S, right? So S is my reorder point, right? So that is when I put my order, right? And this is where the small S is the reorder point. This is the like time. Reorder point is the amount of inventory you have left when you are putting that order. So S is the small like kind of where you are putting that order, how much quantity you are ordering. So that will be capital S minus whatever you have already sold. Sometimes it might happen that you have already gone below S, right? Sometimes it might happen that you have, let's say, your reorder point is 30 kg, some like some product in this store, right? And your maximum inventory level is 100 kg, right? Depending upon requirement, let's say particular day all 30 kg has been consumed. Particular day there is a huge demand, tomorrow or day after tomorrow, 30 kg of that item got consumed, right? So you'll put an order of whatever like 100 kg, but let's say you have 50 kgs left or 40 kgs left, then you will calculate how much you have to order, 100 minus whatever is left out, right? Covers an excessive level of inventory, but again the problem is there will be variation in time, variation in quantity. See, remember, this is always agreement between supplier and like kind of the customer. In this case, customer is the retailer who is selling that item. If you are changing the quantity, right, so there will be always a penalty type. So some discount which you are getting, you might not get. some additional transportation cost also you might have to bear, right? Much effort, much control, right? Because how much you have to order, what is your reorder point, what is your fixed like kind of a maximum inventory level for each SKU, for each inventory product, you have to calculate and carry out those kind of calculations. So it is used in industrial and commercial areas of business, given the fact that flexible order quantity is possible and target quantity can be predetermined, right? So this is where, let's say, business to business, right? They know that, okay, depending upon the customer demand, the business to business demand will change, and they are little bit flexible, right? Because they see quantity, when variation will happen in business to business, quantity, they have that kind of capacity to, like kind of that kind of sourcing capabilities to carry out that. It might not be possible for a B2C FMCG product, right? For a like when I talk about B2B, one plant, one manufacturing plant, let's say Maruti is ordering from, let's say, this chassis, or let's say these seat belts, or whatever kind of, or the like glass wipers, all those things, or tires, right, from MRF or Seat, right? So in that case, what happens? Depending upon what is the like production level, or they have to increase the production level or decrease the production level, so they will be sending that automatically, order will be sent, right? That can be managed there, because see, one big party, one big vendor, a Maruti or one big company, have a strategic sourcing along with the other company MRF, right? From, so these two can be integrated. But imagine the scenario when I'm doing it for a Reliance Retail with 50 other companies, 60 other companies, because Reliance Retail is selling products from not only 50, maybe hundreds or 200 of companies, or much more than that. Managing that will be much more complex, right? For each SKU, and they'll be selling around 10,000 or 20,000 or much more than that SKU in their store. Managing each SKU, what is the inventory level they have to keep? Once the reorder point touches reorder point, order will go, right? So managing that, unless you have an automated system, all the items are scanned, tracked. Once order has been sold, it is getting automated in your system. It is very difficult, right? Not impossible, obviously, because if you have an automated system, everything is being sold, being scanned. Once the item is sold, automatically your system gets updated. Then it's okay. Manually carrying out these kind of activities is very difficult. Whenever both are variation, there is a variation in time it takes to order, or when you are ordering, also the quantity which you are ordering, right? So no need to remember the formula. I'll give you that equation, but you have to remember when to use this kind of formulas, right? So remember, reorder point, the normal equation is, let's say, lead time, how much like it takes. So why we are calculating reorder point? Imagine the scenario, right? That store has 30 kgs of rice, and per day there is a demand of 10 kg, and lead time is 3 days. So in that case, reorder point will become 3 multiplied by 10 kgs, 30 kgs, because the grocery shop owner knows that on an average per day he is selling 10 kgs of rice, and once he puts an order, it will take at least 3 days for suppliers to, or the wholesaler to deliver the items, right? So by the time supplier delivers the item, his inventory, all the inventory would have been consumed, right? So that is where you have a fixed demand, fixed lead time also, right? So your reorder point will be D multiplied by L. D is your daily demand per day. What is the demand per day? What is the consumption or sale happening in your store? L is the lead time. Right? In the normal scenario, what we have discussed, reorder point is nothing but the multiplication of demand per day and lead time, right? But that generally doesn't happen, right? Your demand might be normally distributed during the time, right? So this, let's say, this week or this month, demand might be normally distributed, right? Someday, like, normally distributed means what? It is scattered, or it is centered around a mean, but there is a variation. So your lead time or your reorder point will still remain DL, but there will be certain variation. Some week, some month, there will be increase in demand. Some month or some week, there will be decrease in demand, right? So we are calculating that error. We are calculating that margin of error. Margin of error is nothing but your this Z value, critical value. Let's say for a 95 percentage confidence interval, I'll get 1.96, right? Multiplied by what is the standard deviation? Standard deviation of demand during that lead time, during that 7 days, or during that 1 month. what is the standard deviation of demand. So whenever I have a demand which is normally distributed on that lead time, right? Demand is normally distributed. Not the lead time is fixed, right? Lead time is 1 week or 1 month, whatever is that. But demand might change. For this week, demand might be 10. Next week, demand might be 14. Mean is let's say 12. The D into L might be 12, right? So sometimes it will be 10, sometimes it will be 4, right? So standard deviation, if you calculate, it is coming around 1.8 or 1.6. So this will be your calculation of reorder point. So always if you remember there is a plus sign, right? Because we always try to see that I'll keep extra inventory in case of a, so my I am trying to maintain the customer service level, right? So if you see no here in the confidence interval generally plus minus symbol are also there, right? We put a range. But here if you see whenever we are calculating this reorder point, we are assuming to keep some additional inventory for the differences, because when you talk normally distributed it doesn't mean that always it will be more, it can be less also, right? Some week there will be a decrease in demand, but still we are maintaining that additional inventory because our main focus is to keep the customer service level high, right? We might incur cost in the inventory, we might some additional cost in the inventory, that's why minus symbol is not there. So if you see the wording is little bit different in the second case. If the daily distribution of demand is given, so if I tell like in example terms difference between these two, let's say for that same grocery shop owner, if I know that standard deviation per week in let's say some this milk packets he is selling is 10 units, right? Per week, the standard if I compare last 56 weeks or 52 weeks, the standard deviation in weekly demand, right? Per week demand. So that's why standard deviation of demand during lead time. Lead time is that 7 days. 1 week is the lead time. So let's say per week standard deviation is let's say 10 packets or 20 packets. 20 packets multiplied by this whatever 95% confidence is 1.96, right? I'll add to this much quantity and that will give me the reorder point. So that is one scenario. Second scenario is that when for the last 1 year daily demand right? And there is a variation in daily demand. So some day it is 10 packets, some day 50 packets, some day 20 packets. So now what happens? You have the knowledge about the daily distribution. You are not looking into the distribution across 1 week, distribution across lead time, right? So whenever the daily demand is given, so you will be using the formula again that Z, that critical value multiplied by the this sigma D is different than this sigma DLT. DLT is demand distribution over lead time, right? Over that 1 week or 1 month. This sigma D is demand, daily demand. What is the difference or what is the standard deviation in daily demand? Today you sold 10 packets, next day 12 packets, another day 15 packets, one more day 7 packets. So this variation, this standard deviation in daily demand, right? That will be sigma D square root of L. L is the lead time. If you have a lead time of 7 days or 10 days or 9 days, right? Square root of that, right? Then the other case is when your daily demand is constant, right? Previous case we said demand is varying, right? Lead time is fixed, but in this particular case, lead time is variable, right? So some week the supplier will come within other amount of the product will come within 3 days. Some time it will take 7 days, right? So there is a variation in lead time, right? Then you have to like see, like I said, reorder point. We have to look into both the cases: change in demand, change in lead time. In this case, demand D is constant, but there is a change or standard deviation in lead time, right? And whenever both are there, the last case we saw, right? There might be a change in lead time when you are ordering. Second is there is a change in the quantity of what you are ordering, right? So in that case, take Z out, lead time multiplied by variance of your demand, daily demand, then daily demand square multiplied by variance of your lead time, right? And take the square root. So here you are considering in the last equation, again you did not have to remember the equation. I'll provide you the equation. Only thing you have to remember where to use what, right? Whenever both the variations has been given, daily demand and changes or distribution of demand and distribution of lead time, right? You have to use this kind of formula, which is a combination of changes in your or standard deviation of your demand, how much quantity being ordered, and standard deviation of your lead time, right? Any questions, any doubt up to this point, whatever we have discussed so far? So this is why I discuss this, because these are the same policy which we'll use in some of the part of the software, not all of them. So in the any logistics software, what we are going to use, so these are different inventory control policies are there. Right? Order on demand, just in time, like most for the automobile companies, you order and next day before your productions, you order that much quantity and order will be sent to you, right? MRP plan, depending upon what much, how much you are planning to produce, right? In one shift, let's say 200 cars or 300 cars. In the next shift, you will increase to 500 cars, right? So you have a material requirement plan, MRP, right? So accordingly, your manufacturing schedule will happen. That has been shared with the supplier, and accordingly, they will keep supplying, right? A regular policy, this is the standard, right? So there is no variation. Fixed time, fixed quantity we are ordering, right? Products are ordered, so time is fixed, quantity is also fixed. Here you do not have a safety stock. There might be a chance, or there might be a policy where you are fixed time, fixed quantity, but you are keeping 20 units or 30 units as a safety stock. In case there is a variation, that safety stock will take care of it, right? Then this part we have discussed. You will have a reorder point and you will have a maximum inventory limit, right? Products are ordered when inventory level falls below a fixed replacement point. That is my reorder point. The order quantity is set to such a value that resulting inventory quantity equals to S. So I have a reorder point of 30 kgs. I have a fixed inventory level of 100 kgs. Whenever order falls below 30 kgs, let's say it become 20 kgs, I'll order 80 kg. If it become 10 kgs, I'll be order 90 kgs, right? Something like that. In this particular case, I do not have a safety stock. This maximum inventory, believing that in particular day, customer will have a maximum demand of S, right? If I put a safety stock, that excess safety stock might be there. Sometimes I have to keep that 20 or 30 units additionally. RQ policy, fixed replacement point, fixed quantity, right? When the inventory level falls below a fixed replacement point, that is my kind of same. You see what is the difference between min max quality and this. Here what happens, your quantity will vary. Let's say I have 30 kgs as a reorder point and 100 kg is my maximum stock level, right? Whenever it falls below 30 kgs, whatever is the difference, I'm going to order that. Sometimes I'll order 80 kgs, sometimes 90 kgs, sometimes 100 kgs, right? Or anything in between. But here what happens, whenever it follows below 30 kgs, right? You are ordering a fixed quantity. Whenever you are below that reorder point, you are ordering, let's say 50 kg. So your order quantity keeps same. To that supplier, you always ordering same quantity. But in the min max policy, your order quantity keeps varying. This week you might order 80 kgs, next week 90 kgs, some other week 70 kgs. So that will keep varying. But in the RQ policy, you have a fixed quantity what you are ordering, right? Whenever it follows below the replacement point, that is the reorder point, right? Fixed replacement quantity queue of products being ordered, right? So that is the big difference between min max policy and RQ policy. So these are the few things which will change in the network optimization facility. So for each of the facility, we can manage the inventory control. For a plant, for a assembly plant or a production plant, inventory control policy will be different than the warehouses, right? Product, any product, we know policy type. So these are the policy type which you discussed in the previous slides. Policy parameters, we can change time it takes, we can change the quantity order, we can change the reorder point, we can change the maximum inventory level, T, Q, small s, capital S. So those are the parameters we can change. Initial stock, right? If you remember the last simulation, so in some cases we have to keep initial stock, because whenever the production happens, it will take some time to replacement, right? So you can define what is the initial stock in the warehouses. Periodic check, in some cases you need to track, okay, whenever there is a check every 3 days or 5 days, if there is a reduction in inventory, order will happen. So that also we can simulate. Then period, the number of days between inventory level checks. Policy basis, whether quantity or stage of demand is the policy basis, right? On what basis you are ordering, whether you have a fixed quantity policy or whether you have a fixed day policy, right? Okay, every 7 days you'll put an order, or whenever you are putting order, you'll put a fixed quantity, or both of them. Stock calculation window, the number of days to calculate the mean daily demand, right? So whether, like I said, whether you are doing that periodic check weekly or monthly or bi-weekly, according to your mean, that variation in demand will be calculated. That normal distribution which you took, sigma DLT, distribution of demand over lead time, depending upon your periodic check, whether it is 3 days, 5 days, 7 days, or 10 days, that will be calculated. Time period, again, that is for our simulation, right? Till what period you are looking into your inclusion time, the status of given inventory policy, whether you are including that, any of that I'll show in your software. I think some of it or all of it you are aware of quickly. ABC, annual usage value. So A category is the most purchased or most used product, right? Again, we have to think of for different stakeholders. For a retailer, let's say Reliance Retail or Big Bazaar. So when I take annual usage value, what are the product they are selling? Let's say which are the items, quantity multiplied by the value of the product, right? So quantity multiplied value of the product will give the annual value, right? A category will be the most valued product, followed by B, followed by C. But when I'm talking about a production plant, right? So when I talk about ABC, that is the which raw material which I'm getting, right? For a car manufacturer, maybe the quantity of number of engines, because per engine, per car, engine is only one. But the price of engines is costly, right? For each cost of the engines is 20 or 30% or 35% of the car, right? So in that case, still that annual value will be more, right? For engine, followed by maybe the tires, 5 tires per car. So that will be there. So this is what you have to calculate and find out for each what kind of inventory control policy you want to keep, right? ABC policy is about annual usage value, right? How much total quantity multiplied by the price of that unit. HML analysis, high, medium, low, unit price, right? It is only about the not consumption, how much you are selling. Let's say think about the Reliance Retail. They are selling the electronics product also, right? So some electronics product will be like air conditioners or refrigerators, what they're keeping 30,000, 35,000, 50,000. So they are high value, medium value, low value. But when I'm considering ABC policy, in that case, rice, wheat, all those regular items or clothes, baby clothes, each item is 200, 300 or 100 rupees. But annual usage quantity is much more. So if I'm following ABC value, for me, those items which have a annual selling value is high, I'm much more concerned with that. But if I'm only considering about the unit price, electronics product will be much more, I'll be much more concerned about those products which are costly to me, right? VED, vital, essential, desirable. This is where you are looking into the production plant, right? Because see, maximum what will happen if you go and do not find in a Reliance Retail, you will go to other store, customer will go to other store, right? So you might lose some amount of money, right? But think about a production plant. If engine doesn't get delivered, tires do not get delivered, your whole production plant will get stopped, right? It will not work, right? So vital, essential, desirable will be much more useful in this kind of production plant, processing plant. Let's say you are processing this oil, crude oil could not come on time, right? So your whole refinery is idle, right? You will not be able to work on that. SD is cars difficult DG, procurement difficulties, right? If I'm importing something, let's say this war is happening, same thing I can give that example of refining. So I know that I do not, like India imports around 70% of the crude oil. So they have to be look into the situation. Right now scarcity of crude oil is there, right? So they will be wait for the timing when little bit relaxation happens, war gets over, price comes down, then they will purchase because they know that in future sometimes scarcity might happen, right? And mostly it will happen if you have a like your country doesn't produce. Most of the India gets into difficulties, right? Most of the rare earth materials, crude oil, we do not have that much storage in India, right? So how much difficult it is to source, because if when you are importing, it will take a lot many days. It is not, if it is not within India, it will take lot many days to import all those things. Gulf, government, ordinary, local, foreign, again where from where you are purchasing, right? Whether you are importing it or ordinary items, regular items, local, then foreign, right? Or you are purchasing it from government agencies, right? So, like I said, or I don't know whether I mentioned it or not, most of the government organizations, right? So they want to promote local agencies. They want to promote the national companies, right? So sometimes when they're purchasing from this medium, small scale industries, right? So they provide some price discount to them, right? So if let's say I have a foreign manufacturer, same price, this local manufacturer, right? Up to 4% or 5%. Let's say some same item, foreign manufacturer is giving 100 rupees. If a local manufacturer is giving me within 104 or 105 rupees, still I'll go for that local manufacturer. Seasonal, off-seasonal, SOS, refrigerators, air conditioners, your umbrella, raincoats, all these items will be seasonal, off-seasonal. Some items are off-seasonal, some items are seasonal, right? Off-seasonal means regular, like regular purchases will happen. Seasonal means raincoats will be only required during this July, August, right? Then that purchases won't happen. Fast moving, slow, non-moving. This is much more required for this FMCG retail stores, right? Because they want to keep those products where inventory turnover is more. Quickly they can sell that item. If the brand is saying no, keep my product, but it is not being sold, customers are not buying. So they have to keep track of this also. Apart from ABC analysis, they have to keep track of which are the products not moving. So if you see, the lot of time there will be a fight between this brand ITC, FMCG, ITC, HUL, PNG with this modern retail outlets. Because brand will be forcing, no, you have to keep all my brands, all my products, right? But that company will be telling, no, these items are not being sold from your, even like small grocery shops also. If you go and ask any brand goes and keep my product, they'll directly refuse. I do not have space. Your products are just only taking space. Nobody is buying that, right? So that's why a small company getting that space in any like even a small grocery shop will be very difficult. If you let's say start a small FMCG company or any like product which you are trying to sell to customers, right? Getting that space is very difficult, right? Then XYG inventory investment, right? So this is where you have to think of how much capital investment you have done to keep that inventory, right? In some cases, like I said, it will need additional storage, it will need additional transportation for particular items, right? For modern retail outlets, particular items, let's say ice cream, soft drinks in summer month, you have to have a cold storage, you need to have a refrigeration system. Let's say you are selling frozen foods, right? You need to have that kind of rack, refrigerated racks where you can show, display, customers can come and see and purchase that item, right? That needs a additional inventory investment. Clothes, normal items, which are like daily regular items, you can store anywhere, right? You need not need additional inventory investment. So according to that also, you can categorize what kind of inventory you have, right? So most of the like ERP system softwares, they will have kind of complete inventory like this SAP. If you go, they have a material management model. So they'll keep track of where the inventory is coming, where it is getting processed, how much inventory is left, when to order. So all these things most of the times has been integrated. If you're working in a big company, right? A lot of data, a lot of information will be available in the system itself. You do not have to do many manual calculations. But yes, some cases if that system is not there, still you have to do those calculations in Excel, manual check, sign it, and send it out. Even like I was talking to some of your seniors who used to work in ITs, right? And some of the warehouses still kind of they do it all those things manually, right? Then part of the inventory control next part is warehouse management, right? When you talk about warehouse inventory control, where you are looking about the checking inventory regularly, manual check or periodic check, look into how much quantity is left and ordering it, right? So that is where your fixed order, fixed unit order or fixed time order, right, will come into picture. But when you talk about the warehouse management, right, receiving products, putting away, storing items, quality assurance. If it is a production plant, quality assurance processes will be there where they'll check whatever raw material is coming, whether they're okay or not. Quality control has to happen. Warehouse operations, track warehouse activities, maintain and optimize warehouse activities. As a warehouse manager, you have to remember you have a fixed space, right? You have to optimize that, right? Even within a plant, obviously, warehouses will be little bigger in manufacturing plant, but still it is a fixed space, right? You do not have an infinite amount of space. Outbound operations, prepare shipment, packing operations, peak items, consolidate shipment, ship product. Think about an Amazon warehouse, right? Picking item. So today's exercise, I'll show you a video. I'll give that link. So how like kind of automation helps in that picking items, right? So you like if you search and Google on the Amazon warehouses, automatically robots are going picking the items, coming to the last where the transportation will happen, packaging is happening and going on. Almost 60 to 70% of the automation already has happened, right? Then ship product consolidate shipments. Let's say if it is going to a particular location, let's say from the Kolkata, how items will go to Bihar, Odisha. So all things need to be consolidated. Okay, this many trailers or trucks will go to Odisha. This many vehicles will go to Bihar. This many to Chhattisgarh, right? So that need to be tracked, right? Unless you have automated system, your life as a warehouse manager, if some of you get into that, it will be like kind of hellish, right? Every night you will get a call that this items are missing, this stock like got stopped somewhere, right? So manually maintaining control of that become very impossible in today's world. Maybe a small company can still do that. For a bigger company, it becomes a very big challenge. So this is like this again we have discussed the some of the activities of a warehouse management system. Again, like I said, there are a lot of softwares who have starting with SAP, Oracle, Ariba does in supply chain management. A lot of softwares are there who are maintaining this warehouse management system. Preparing data, then receive goods, inspection, put away, delivery order, picking is picking from the wherever racks you are keeping the items, right? Packing, then inspection, then shipping, right? So typical warehouse, if I look into where to store, so there will be machines which will go and store the items. Inventory need to be tracked. Inventory need to be properly like kind of record need to be maintained. Label need to be printed. So if you just think about Amazon warehouses, how many labels they are printing and putting on your each of your invoices in of your each of your packages, right? So you need that system also, right? And then obviously dispatch, then Wi-Fi barcode system to scan the product codes, know that okay where that product is going and how when it is going to reach, right? So now this is the interesting and your class exercise. Please go through the YouTube video which I'll share in that Google Classroom. That is an interesting debate and there are a lot of mathematics to it, but don't worry about the mathematics, but think logically, right? Generally what happens if I say that okay, how like if I say that okay, I am the warehouse manager in Amazon, I have 50,000 or 1 lakh SKUs which I'm maintaining. If I know where I am putting my items, where the SKUs, let's say particular SKUs regarding clothes in the left section of my warehouse, toys, children's items in the right section, right? Like let's say these are my fixed places where inventory is kept, right? So that is one scenario. Second scenario is randomly, right? Whenever items come from supplier, I randomly keep it. Obviously that's candid. Randomly doesn't mean that I do not have a location data, but idea or assignment of location is random, right? So there is not a fixed place that okay, clothes will be only kept in the left side of the warehouse. That is not like that. But obviously each cloth, the tag, the label is there, so I can know that okay, where in the particular warehouse the clothes or the toys or the any item what you or electronics being sold. So if you look into these two, random and fixed, random sorting means the items are not assigned to fixed peak slots where it is kept, right? Zones. Yeah, and a fixed one, right? So there was actually a very good, great article where they compared, right? For a big warehouse like Amazon, if I have a fixed slots and random slots, it they found out that strangely and against our intuition, if they're keeping items randomly, right? So they're getting much more benefit, right? And I have shared that video with you. Go through that, and you'll see that okay how it is happening, right? This is like kind of a mix of both random and fixed. You have a zone, right? But within that zone, your items keep changing, right? So it is basically Dynamic slotting means peak slots of the items are not fixed but keep changing. However, unlike random slotting, peak slots are assigned by WMS based on the predefined criteria. So these part is at least fixed. The WMS or the warehouse management system, WMS warehouse management system will fix the zones, right? Within that zone, your what items you are keeping will keep changing, right? But in the random, anything like wherever you can keep, whenever the order comes, you keep it, you scan it, you put a label, put it somewhere, right? For example, items that are high demand are being located closer to the shipping area in order to accelerate the order fulfillment process. Depending upon when the, like, let's say, so for this you need certain artificial intelligence. Holi is coming, certain items, or Diwali is coming, certain items will be huge in demand based on the past data. Accordingly, those items will be stored near to the like shipping location because lot of transportation can be avoided, right? Certain festivals or certain like sales you are maintaining, electronic sales are happening, 20%, 30% discount. You know that lot of people will buy those items. So for that week, for that month, you will keep those items near the dispatch location, right? Near to the transportation hub, right? So random fixed, random is anywhere, anytime it can be changed. Fixed is locations of items where you are keeping those product inventory is fixed. Dynamic is depending upon the requirement, depending upon the customer demand. Your locations will keep changing and that will be assigned by the WMS, right? So these are the inventory slotting processes strategy, right? And this comparison is actually good. Like 2 years back when I came across this article, I was really interested that how it is happening, how like random slotting is performing better than fixed slotting, right? Which is little bit against counterintuitive, right? I think that's my last slide. Any questions, any doubt? I'll put this video. Please go through it. 3 minutes or 5 minutes video, but that is interesting. Any last questions, doubt? Okay. If not, chalo, take care. Bye bye.
For attendance.
Okay, yeah, 225.
So
Yes, sir.
349.
349. Okay. Anyone else?
0 to 1. 0 to 1.
215.
215. Yeah, I had taken yours. Initially, who had joined, I had taken theirs. If Sita's Suyasi, then Sweta. Okay. Anyone who joined late?